Hello. So this video is all about the one-way ANOVA for repeated measures. By definition, a one-way repeated measures ANOVA, also known as within subjects ANOVA, is used to determine whether three or more group means are different where the participants are the same in each group. Okay. So our situation is an instructor wants to make a long test for a certain topic. However, she needs 20 participants that will take the test 5 times to determine if it will produce a consistent results. The test results were as follows for test 1 to test 5. So we have here the 5 tests for test 1, test 2, test 3, test 4, and test 5. So each test or each group had 20 samples, so the total of 100 samples. So now let's proceed to the calculation of results. So we are now here in one-way repeated measures ANOVA calculator. So we already pasted the 20 samples in each treatment for treatment 1, for treatment 2, 3, 4, and 5. So we have a total of 100 samples. So the significance level is set to 0.05, and now let's calculate. Okay, so these are the results. So we have here the F ratio value is 0.23874 and the P value is 915591. So the result is not significant at P is less than 0.05. Okay, so to sum up the results, this is the narrative discussion. Objective: is there a significant difference in the raw scores of each long test? Null hypothesis: there is no significant difference in the raw scores of each long test. Significance level is set to 0.05 and the CI is 95%. Normality test based on p-value. For test 1, 0.77953 normally distributed. Test 2, 0.45625 normally distributed. Test 3, 0.92926 normally distributed. Test 4, 0.71725 normally distributed. And test 5 is 0.54836 normally distributed. Results. Result 1. The mean of test 1 is 38.2. The mean of test 2 is 37. The mean of test 3 is 36.8. The least average mean or the least average or mean. The mean of test 4 is 37.3 and the mean of test 5 is 38.75 or the highest average. Interpretation: test 5 had the highest average and test 3 had the lowest average. Result number 2, ANOVA based on probability value is equal to 0.915591. Interpretation: the hypothesis in null form will be accepted since the computed probability value is greater than the significant level of 0.05. Therefore, there is no significant difference in the mean score of each long test. Data analysis: the given dataset had been tested with one-way ANOVA for repeated measures since the participants are in the same in each group or they are related group. Each group had been tested with Kolmogorov test of normality with a result of computed p-values such as 0.77953, 0.45625, 0.92926, 0.71725, and 0.54836 for test 1, test 2, test 3, test 4, and test 5 respectively. These values suggest that the datasets in each group were normally distributed since their computed p-value is greater than 0.05. It was also found out that the test 5 had the highest average and test 3 had the lowest average. On the other hand, treating the two datasets or 5 datasets with one-way ANOVA for repeated measures, it yields a p-value of 0.915591, which is greater than 0.05. Since p-value is greater than the significance level, the null hypothesis will be accepted. Therefore, there is no significant difference in the mean score of each long test.